Okay, here's another of our energy questions that we're going to look at today. And we've got a wind farm here, so we've got a wind turbine arrangement here. It says state two methods which could be used to reduce friction, reducing friction in the wind turbine. Well, first of all, the turbine shaft will be mounted on bearings, so you could have better quality bearings. Probably roller bearings, something like that. And we've got a lot of cogs moving around inside the gearbox, so we want to reduce the friction there, so probably use a better quality lubrication, oil or some such like. Okay, moving on, we've got an efficiency table. It says the wind turbine is simplified in the block diagram below. Here's the wind energy going into the rotor blades and the electrical energy coming out of the generator. It says the wind turbine produces 6 megajoules of electrical energy, but is only 24% efficient. So we're losing quite a bit. Let's write down the efficiency formula first, which is output energy divided by input energy. Okay. It says 6 megajoules is produced, so that is actually the output energy. So 6 megajoules is the output. However, we don't know what the input is, but we do know the efficiency is equal to 24%. Now 24% is actually 0.24 as a ratio between these two, and if you transpose this formula you just need to swap these two over. So 6 megajoules divided by 0.24 should give us our unknown quantity of energy in. So back to the calculator, 6 divided by 0.24, and the answer 25 megajoules. Not a very efficient system. Okay, second part of this question. There we go. If the output energy of the rotor blades is 16 megajoules, calculate the efficiency. Again, straight in with efficiency. Output energy divided by input energy. Now you've got to have calculated the 25 megajoules as the input energy to the rotor blades. It does give us 16 megajoules as the output. Back to the calculator, 16 divided by 25 equals, well, it says 0.64, and that's the ratio between the two. If you want that as a percentage, you have to multiply that by 100, and that gives us 64% efficiency. Then says state one form of energy, waste energy given out by the gearbox. Well, the gearbox got a lot of cogs in it, all meshing together, a lot of friction going on. So the energy form that we're going to lose is heat. And then says state two examples of finite. Well, you've got to know that finite means it's not infinite. It will run out one day. So examples of finite energy are coal and oil. You could also have natural gas. Wind power is one form of renewable energy. This is what we like. State two advantages other than cost of wind power. Well, wind power will never run out. Unlike fossil fuels. and also wind power does not produce CO2. Now this means no global warming. CO2, very bad greenhouse gas. And so state 2 disadvantages other than cost of tidal energy. Well, tidal energy is produced as the tide rises and falls due to the gravitational effect of the moon and the sun. But there are 2 times of the day when you don't get tidal energy, and that's at high and low tide, no energy produced. But it says 2 disadvantages. Well, very awkward to mount them just anywhere. You have to be at the coast for a start, and not just anywhere at the coast. You have to have a good tidal flow, or anywhere that doesn't cause marine harm. So there's not many places where tidal can be utilized, and this is only at remote areas around the coast. And that is that.